Okay, so this was the question of first lecture, that how will you synthesize methyl iodide from methane. So let's start the discussion. We have CH4 methane, okay, and we need to synthesize what? CH3I. CH3I is the target. So methane, the first, in case of methane, and as we know that direct iodination is not possible, direct chlorination is possible, even direct bromination is also very difficult, although we have one method for that, okay. So either we can go for that method, that means either we can prepare a chloro derivative or bromo derivative first, and then we move for that, because you know that there is a reaction of exchange of halogen. So if you have a halogen of different, then you can exchange with this iodine also, so we will follow that. So CH4, we can go for a very simple method. We all know that direct halogenation is possible in case of chlorine in presence of sunlight, okay, sunlight. So this will give you what? CH3Cl, and this CH3Cl can be easily replaced with one of the salt, that is sodium iodide, and this will give you CH3I along with NaCl. So this is a simple method. So here is what? Here is direct halogenation. Here we have used direct halogenation, okay. And here is what? From this to this we have a name reaction. That name reaction is what? Finkelstein, where exchange of halogen, exchange of halogen. So this is very simple answer. Thank you so much. So these are the questions which I had asked to you, and let's let's discuss these question. Identify the compound which will undergo SN1 reaction faster. So very simple. We know that the S1 SN1 reaction is faster in tertiary carbocation than primary, secondary, and the primary. So order of stability of carbocation is what? This. So we need to check which one is the tertiary, which one is the secondary, and which one is the primary. Tertiary will be faster. So this carbon, as you can see that this is a tertiary carbon, which is because it is bonded with the three different methyl groups. So without any doubt, this will give you uh, faster SN1. So this will give you faster SN1, okay. Now in the second, we have a two choice again. So in this case you can see that this carbon, this is a carbon, so this carbon is bonded with this carbon and this carbon, so this is what? This is a secondary carbon, okay. And if you look to this carbon is bonded with one carbon here, one carbon is here, and one carbon is here. That means this is a tertiary carbon. So undoubtedly this will give a faster SN1, okay. So first is A and second one is the B. Now an acid having molecular formula C3H5O2Br, and it is optically active. So what is the structure? And the hint is given, optically active. That means we have a carbon which have four different substituent, okay, four different, and it is optically active, says it is sp3 hybridized, okay. So for optically active, what we required for a different group, and it is C3. So we have one carbon, we have another carbon here and another carbon and here, okay. So it is a C3, then it is optically active. So of course this carbon is bonded with carbon here and carbon here, and we can bromine here, we can put bromine here. So one more we required, and we have two oxygen also, and H5. So I think if you go for this will give you a CH3. So we required only one hydrogen left. This had sorry, two hydrogens, so this hydrogen we can put here. So now we have three different group: hydrogen, methyl, and bromine, okay. and here we have what left, we have two oxygen we have remaining, and 3 and 4, so one hydrogen, two oxygen and one hydrogen, two oxygen and one hydrogen, this will be acid. So this is the formula, and name is what, 2 bromo, 2 bromo propanoic acid, propanoic acid. So this is again a simple one. Thank you so much. So these are the questions which I asked you in lecture number third. Let's start the discussion. Which compound in a given pair will react faster in SN2 reaction? We had already discussed in detail. SN2, the order in case of SN2 is what? SN2 1, 2 and 3, and in case of SN1 it is 3, 2 and 1. So here as you can see that okay, this will solve with the help of this discussion. So here we have third degree and here we have 1 degree. Okay, this is third degree carbon, this is 1 degree. So this one, this will be CH3Cl. Okay, no, sorry, SN2, no, it is for SN2, SN2. So this will be this. So first is the reactivity reason, first reason is reactivity, first reason is reactivity, and reason why it is reactivity, because of steric hindrance, less steric hindrance in case of this, and where in this case which okay. And here as we know that the leaving group ability, so the leaving group ability is higher in case of iodine, whereas in case of bromine it is relatively lesser. So CH3I is a better leaving group, so this will be the answer. Okay, so reason is leaving group in this case, steric hindrance, less steric hindrance in this case. Now moving ahead, the second question. Here we have to predict which one is based on the SN1 and which one is based on the SN2 with the proper reason. So as the first, you can see that here we have a protic solvent, this is the protic, and this is the aprotic solvent. Okay, so as you know the difference of protic and aprotic solvent, so protic solvent favor in case of SN1 and aprotic is favor in case of SN2. So this will follow the SN1 and this will follow the SN2. This is the first reason. Okay, protic and aprotic solvent. Then the second reason is what, you can see that this is the carbon, so this carbon is bonded with this carbon and this carbon, so this is what, second degree carbon, and this is the 1 degree carbon. Okay, and we know that the order in case of SN uh, 1 is what, SN1 is follow the third degree and second degree and 1 degree. So this is more reactive, so this is again the SN1, and in this case S2 and 3, so this is SN2. So two reason for this answer, for this question. First reason is of protic solvent and second reason is the reactivity. Okay, reactivity order follows the third 3 to 1, here 1 to 3. So this is the answer of the question. Thank you so much.